In this video, we're going to take a look at the inverse functions for the sine, cosine, and tangent functions. When you think about the inverse, recall that in order to find the inverse, you first have to take your function, switch the x and y values, and then solve for y. So when doing that with the sine function, you end up with this equation, y equals the inverse sine of x. Sometimes you'll see it referred to as the arc sine of x. These just mean the same thing. Now, if we consider the sine function, so here's our sine function, graphing 2 cycles, we know that in order for an inverse to be a function, your original function must be 1 to 1. And clearly this is not 1 to 1 because it does not pass the horizontal line test, right? If we draw a horizontal line, it's going to intersect the same y value at more than one place. So in order for our inverse function to be a function, we need to restrict the domain of our original function so that it has all of the values that are in the range of our original function, but is then 1 to 1. Now, the reason why we want this restriction to have all the values that are in the range is because we know that when you take the inverse, the range of your original function becomes the domain of your new function, and the domain of your original function becomes the range of your new function. So if we're missing any values in the range, that means we're going to be missing values in our domain for the inverse. So when looking at the sine function, we need to find an interval that has all of our values in the range, so everything from 1 to -1. And we want it to be continuous, and ideally we want it to at least start at 0 or go through 0 through the origin. So if we tried to restrict our graph, let's say from 0 to 2 pi, right, just with the first cycle, well, we can still see that it would not be 1 to 1. It would still fail the horizontal line test. But it would represent all of the values in our range. So we need a place where everything from 1 to -1 is covered. And that's actually going to happen. The restriction that we're going to use is from -pi/2 to +pi/2. So this is in the values in quadrants 1 and 4. Now the angle measures in quadrant 4 are going to be negative. They're going to be negative angle measures. And the reason why we want to use the negative angle measures for quadrant 4 is if we used the positive measures, that'd be from 3pi/2 to 2 pi, our graph would be discontinuous. From 0 to pi/2 and then 3pi/2 to 2 pi would give us a discontinuous graph. So we're going to use the values from -pi/2 to pi/2. So when thinking about the sine function in the first and fourth quadrants, what's true about the angles? Well, in the first quadrant, we know that all of the measures of the sine are positive, and all of the measures for the sine in the fourth quadrant are negative. So when we take the inverse, if we're taking the inverse of a positive measure, that's going to give us an angle in the first quadrant. And if we take the inverse of a negative measure, that's going to give us a value in the fourth quadrant. So again, for the sine, the reason why we had to restrict the values from -pi/2 to pi/2 is so that our inverse would be a function. And we wanted it to be from -pi/2 to pi/2 because that gives us a continuous function that goes through the origin. All right, so let's take a look at the inverse cosine. For the inverse cosine, we're also going to be restricting the domain. But for this, we're going to restrict the domain from 0 to pi radians. So again, from 0 to pi, we get all of the values in our range from -1 to 1. And it represents a continuous curve. So that's going to be the domain restrictions for our sine that will give us the values of our inverse cosine. And so the inverse cosine is going to be angles that's going to be quadrants 1 and 2. So if we think about the cosine, remember the cosine represents the x coordinate in the unit circle. And we know that the x-coordinate in the unit circle is positive in quadrant 1 and is negative in quadrant 2. So if when we're evaluating the inverse cosine, the value is positive here, that's going to give us an angle measure in quadrant 1 as a result. If it's negative, it's going to give us an angle measure in quadrant 2. And lastly, we're going to take a look at the inverse tangent function. So the inverse tangent function has a bunch of cycles, right? And they're separated by these vertical asymptotes. Now, the range is all real numbers. It goes from negative infinity to positive infinity. And so we need an entire cycle that represents all of that and also gives us our undefined values with our asymptotes. And so it works out perfectly for this tangent function to just use this middle this middle cycle. So from negative pi over 2 to positive pi over 2. This cycle is the perfect cycle to use because it's centered at the origin and it represents all of the values in our range. So that's going to be angle measures in quadrants 1 and quadrants 4. Now again, just like with the sine, all of our angle measures in quadrant 4 are negative angles. Right, they're negative angle measures. And we can see that here, right? We go from negative pi over 2 to 0. So those are going to give us negative angle measures. And that's going to be just in quadrant 4 in this direction. So thinking about the tangent function, the tangent in quadrant 1 and in quadrant 4. In quadrant 1, the tangent, the value of the tangent is positive, right? And in quadrant 4, the value of the tangent is negative. So when taking the inverse tangent, if the value that you're taking the inverse tangent of, that you're evaluating, is positive, your result that you get out is going to be an angle measure in quadrant 1. And when taking the inverse tangent of a negative angle, your result is going to be an angle in quadrant 4, again being a negative angle in that quadrant.